Welcome to Deliverable 3 and Team Progress Report of the Fired Up Benchmarking Dodo Drones Project, Knowledge-Based Lab Interpretation. My name is Mike Rapetti, and I will be your narrator. In this presentation, we will be discussing three main topics: our team's recent accomplishments, the current state of our application, including details about each of its main components, and next steps for the project. Over the past few weeks, we've created most of the individual components of our application. At a high level, as front-end developer, Brendan created a web-based user interface. Our back-end developer, Gordon, wrote Python code to perform all of the server-side application functionality. In his architect role, Chad set up a Docker container to deploy our app. He also configured a local file server to test it. Finally, as project manager, Mike gathered CDS rules and requirements from our external mentor. He also planned the work breakdown and assignments for the final project phase. Referencing the architecture diagram shown here, we'll explore the current state of our application in more detail by talking through each component individually. The remote file servers provided by Georgia Tech don't contain observation data with the LOINC codes needed to properly exercise our application. So Chad configured a local file server that resides inside the Docker container and is deployed as a resource alongside the app itself. After populating it with relevant data, this is used to test the app. For example, here we see an observation retrieved from the local server with LOINC code 1742-6, an important liver function test. Our external mentor, Dr. Park, expressed a desire for the liver function test, or LFT, rules to be easily maintainable. So Mike designed a spreadsheet format that is human readable and intuitive to edit. Further, it is saved as a set of TSV files that are automatically read and processed by the Python code running the app's backend. Here we see three logic rules along with corresponding text to display if they're triggered. This text includes background education and recommended action for the provider to take. Gordon wrote the server-side application Python code. It may not be much to look at, but it's definitely where all the action happens. Key functionality includes retrieving patient observation data from a file server, applying liver function test clinical decision support rules against it, and returning relevant education and recommendations tailored to a clinician. Also included are utilities to manage the local file server's data. Brendan developed a clean-looking web-based user interface for the front end of our application. It is designed with minimal visual distraction, tailored for busy clinician users. Here we see the landing page. The main input is unique identifying patient information, specifically name and birth date. In this early test case example, the name 1BDD is entered. Here we see results for patient 1BDD returned as a JSON object. And note that one of the liver function test rules was triggered based on data retrieved from the file server. Specifically, this patient has moderate elevation in AST and/or ALT and should be assessed for disorders like hepatitis and drug-related injury. There is also a link to a PubMed article with supporting documentation for this reasoning. Looking ahead, we will split the Deliverable 4 phase into 3 week-long sprints. In week 1, we will expand our app's functionality. Dr. Park clarified that over time, a patient may have multiple liver function test observations, and a clinician user needs to choose which one to display in detail. So we will update our test data, backend functions, and the user interface to support this scenario. In week 2, we will refine the app. This will include rigorous user testing and bug fixes, plus fine-tuning the user interface to cleanly display test results and provide user guidance. Finally, during week 3, we will ensure Docker and Jenkins are both configured to seamlessly deploy the app to our TA mentor for grading and our external mentor for further testing and use. By this time, it will be a fully contained proof of concept for a Smart on Fire app delivering clinical decision support for liver function tests. More broadly, it will demonstrate the ability to provide, as the project name suggests, knowledge-based lab interpretation.